All right, for the last example, since determine if x minus 6 is a factor of p of x equals all that stuff. If it is a factor, then write p of x is a product of x minus 6 and the reduced polynomial q of x. All right, so there's p of x, q of x, reduced polynomial, factoring, all this kind of stuff going on here. This is just an application of what we've been doing in this chapter, division of polynomials. Now, if I want to see if x minus 6 is a factor, so let's focus on that part of it. Determine if x minus 6 is a factor. All right? If something's a factor, that means if you divide it, you should get a remainder of 0. So all we have to do to determine if x minus 6 is a factor is divide the polynomial, which is this, by this, using one or the other techniques, either synthetic division if we can, or long division if we can't. All right? But obviously we can synthetic this time, right? So we will. But if it said determine if 2x minus 5 is a factor, we can't use synthetic division there. Now we have to use long division. All right? So if we're determining if something is a factor, the way we do it is we divide the polynomial using one of the two valid techniques for division and get a remainder of 0. All right? So let's do that real quick. So if I'm doing synthetic division, I'm going to put what in this box?
6.
Positive 6, because we changed the sign. We're dividing by x minus 6. Positive 6 goes there. And then the coefficients of the polynomial we're dividing by come from here. So we have 1x to the 4th, we have negative 8x to the 3rd, we have positive 16x squared, we have negative 23x, and we have negative 6. Every power of x has been accounted for, 4, 3, 2, 1 constant. So no zeros are showing up in my synthetic division setup. Every sign is what it is in the problem. This is positive 1, that's negative 8, that's positive 16, negative 23, negative 6. And I bring my number straight down like so. So I get my setup proper. If I don't set it up properly, I can't get the right answer. So again, take your time on that step. Make sure everything gets set up exactly like it should be. This should be the opposite sign. Those should be exactly what the signs are. This number gets brought down. We multiply to get up. 6 times 1 is 6. We add to get down. Opposite signs subtract, 8 is bigger negative. Multiply opposite signs gets negative 12. Opposite signs subtract, positive 4. Multiply same signs, positive 24. Add different signs, subtract, positive 1. Multiply 6 times 1, positive 6. Subtract, we get 0. So notice our remainder, which is this guy, is 0. So it says determine if it's a factor, we get a remainder of 0, it is a factor. So as far as that question is concerned, since I got a remainder of 0, it is a factor. So yes, x minus 6 is a factor of p of x. Okay. The work necessary to do that is right there. And this work is also going to get us more information too, so that's helpful. All right? So, everybody comfortable with that part of it? Again, if this were not x plus or minus, we'd have to do long division to do the same thing. But again, no remainder means, a 0 remainder means that it is a factor. If I got a remainder of 7, if this said 7, it's not a factor. Nothing else happens at this point. If it's not a factor, it doesn't factor.
So only like 0?
Yeah, only remainder of 0, it means it can factor. Anything other than 0, it does not factor. And if it does not factor, the rest of this is moot, right? Because if it is a factor, then do this other stuff. If it's not, you're done. All right? So if the answer is no, if the remainder is 25, no, done. Circle no. All right? But if the remainder is 0, the answer is yes, then you've got to continue on to factor. So let me try and make some sense out of the rest of this. If it is a factor, write p of x. P of x is this guy right here, right? Right, p of x as a product of x minus 6, which is what we divided by, right? And the reduced polynomial, q of x. Reduced polynomial is our answer. It's our quotient. Used bad colors there, but can we all see the 1, negative 2, 4, and 1 in there? All right. So, wish I had a different highlight color than that purple, but oh well. It's called q of x because it's a quotient. Q for quotient, right? So the reduced polynomial is the answer to the division. We divided by x minus 6. So our p of x is simply going to be what we divided by times whatever we got as an answer, which again, remainder 0, this is constant, x to the first, x to the second, x to the third. So 1x to the third minus 2x to the second plus 4x plus 1. Pluses and minuses in between terms based on their signs. The first term positive, don't have to write a sign. Everything after has to have a sign. So -2, +4, +1. And again, remainders there, constant, x to the first, x to the second, x to the third. So this times this is the same as that. That's a factored form of it. It's not completely factored. Obviously, we still got a cubic function here, but we've at least broken it down some. Something times something to make the original. So that's the second part. Whatever you divided by times whatever you got as an answer is equal to p of x. That's how you factor it if you have a remainder of 0. If you have a remainder other than 0, you write no and you're done. If you can divide synthetically, please do. If you can't divide synthetically, go long division. Again, if it's anything other than x all by itself, plus or minus a number, synthetic division will not work. It's not possible without doing some weird things to everything and confusing everybody. So we'll just say it's not possible unless it says x plus or minus a number. All right. Otherwise, use long division. Get the answer that way.